Welcome to MyProjectBazaar.com. Let me discuss about the project Minimizing Movement for Target Coverage and Network Connectivity in Mobile Sensor Networks. Let me discuss about the abstract of the project. The emerging technology of wireless sensor network is expected to provide a broad range of applications such as battlefield surveillance, environmental monitoring, and smart spaces and so on. Sensing coverage and network connectivity are two of the most fundamental problems in wireless sensor networks. Sensor networks are used in numerous applications, environmental monitoring, power grids, etc. Large-scale sensor networks are deployed in numerous application domains, and the data they are collect are used in decision making for critical infrastructures. Data are streamed from multiple sources through intermediate processing nodes that aggregate information. Data are produced at a large number of sensor node sources and processed in network at intermediate hubs on their way to a base station that performs decision making. The diversity of data sources creates the need to assure the trustworthiness of data such that only trustworthy information is considered in the decision process. Finding an optimal node deployment strategy that would minimize cost, reduce computation and communication overhead, be resilient to node failures, and provide a high degree of coverage with network connectivity is extremely challenging. This project proposed a heuristic algorithm to reduce the total movement distance of sensors. Let me discuss about the flow diagram for our process. Initially, we generate the model, that is network model. This model is adapted for both sensing and communication of sensors with the sensing radius RS and the communication radius RC respectively. Each target can be covered by more than one sensor, and each sensor can cover more than one target. Target is set covered if and only if there is at least one sensor in the disk of radius RS centered at the target. Disk is defined as the target coverage disk, and the circle of the coverage disk is called the target's coverage circle. Next, initially we perform the basic algorithm. The algorithm first finds out the set of targets to be covered and the set of mobile sensor to be moved. It finds a minimum click partition on the graph of targets in tree coverage for every click and every sensor in the S-rest. Potential destination and corresponding movement distance for the sensor to cover targets in that click is computed. Next, in the TV greedy algorithm are going to be performed. The target-based Verne greedy algorithm is to deploy a nearest sensor to cover the targets that are uncovered. TV greedy starts from the generation of targets Verne diagrams, which divide sensors into independent groups for each target. With assistance of targets Venn diagrams, we can construct a sensor group for each target, which includes sensor in proximity of this target. Next, in the ECST algorithm, first we construct an edge length constraint stainer tree spanning all the coverage sensors under the sink, such that each tree edge length is no longer than RC. Stainer tree is required to minimize the number of sensors that need to move. Second, we relocate rest mobile sensors to the generated stainer points to connect the coverage sensors under the sink. For the second step, it is actually a special case of TCOB in which the stainer points are regarded as target and the coverage radius is 0. Next, in the ECST-H algorithm, that is extended ECST algorithm, with the output of SP of the ECST algorithm, next step is to assign the rest mobile sensors one by one to each point in SP with the minimum movement. Since it is actually an assignment problem, it can be solved using extended Hungarian method. Its computation cost of 2 parts. Finally, we perform the performance analysis. Here we achieve the total movement distance using mobile number of sensors. Let me discuss about the running procedure for our process. Select the main file.m file in the current folder, directly will run for executing this process. This is the main window of our process. Initially enter the number of nodes to be deployed, which between 100 to 50 nodes, and enter the region, the network, and enter the number of targets. Sensing radius is 10 meter. Initially we perform the sensor deployment. By pressing the sensor deployment button, we can perform the sensor deployment. Here the sensor nodes are deployed randomly, and they are turn into the number. By pressing the target deployment button, perform the target deployment. Here the red color node represents the target which are deployed, and by pressing the basic algorithm button, we can perform the basic algorithm operation. Pressing the basic algorithm, we can perform the basic algorithm, and we obtain the network lifetime as 2300. Pressing the DV greedy algorithm, we go for the DV greedy algorithm window. Pressing the DV greedy deployment button, perform the DV greedy algorithm, we obtain the network lifetime after deployment. Obtain the network lifetime using DV greedy deployment. By pressing the X Hungarian algorithm, we going to the X Hungarian algorithm window. By pressing the X Hungarian deployment button, we can perform the Hungarian deployment algorithm. Here we obtain the X Hungarian network lifetime result, and finally we going to perform the performance graphs. Pressing the performance graphs button, we obtain the graphical representation of our output. This is the total movement distance between number of mobile sensors. By varying the mobile sensors, we obtain the total movement distance. This is the by varying the number of mobile sensors, obtain the total movement distance for various algorithm. And this is the by varying the number of targets, we obtain the total movement distance between among various number of algorithm. Here we obtain the number of total movement distance for various number of targets, and this is the by varying the mobile number of mobile sensors, we obtain the total movement distance for ECST EBT algorithm, and here we also obtain the total movement distance by varying the number of targets. Here we perform the sensor deployment with various algorithms, basic algorithm, TV algorithm, X Hungarian algorithm. Finally, we analyze the X Hungarian algorithm is outperform compared with other algorithm. Thank you.